Hello, everyone. Thank you for joining us today. I am Jim May, Marketing Manager at Index Corporation. I'm going to turn things over to Craig Foster and Mike Huggett in just a minute. But to get things started, I wanted to let you know a lot of people are still working from home. If you are working from home and are on your company's VPN, you may want to try unengaging the VPN and just joining us directly online. That will probably make for a little bit better viewing experience. Also, you should have in your panel where you can see an option to ask questions. If you have any questions during or after the presentation, please enter them there. We will save those to the end, and then the guys will address those before we go. So with that, I will turn it over to Craig. Thanks for joining us.
Great. Thank you, Jim. And welcome, everyone. Good afternoon, and welcome to Index Trob's webinar, The Benefits of a Third Turret. It's being presented by Mike Huggett and myself, Craig Foster. I want to welcome all of the people that have joined us, our current customers, prospective customers, but I also want to thank all our sales colleagues who have joined. We know we've got a lot of the tooling individuals on here, as well as our current distributor network and even competitive distributors. So I wanted to thank you all for joining. Mike and I have put together a webinar. I know that people are a little bit webinared out these days, so I will do my best not to talk in an NPR voice. We split it into two categories. I will be doing an industry perspective on the benefits of a third turret on machines. My name is Craig Foster. I'm the Upper Midwest Regional Sales Manager. I've been with Index a little over 3 years. I have 26 years in the industry. Mike will be doing the Index perspective. He is the National Sales Manager at Index. He has over 3 years at Index and over 29 years in the industry. So jumping right into it, we want to talk about boosting capacities and capabilities. So we've got immediate productivity gains with a third turret machine, the ability to process more complex parts, and additional processes to provide flexible options. And we'll drill down to each one of these as we move along here. So getting into immediate productivity gains, we've got more tools in the cut. This is just simple math. If I've got more tools overlapping, I'm going to get a great reduction in cycle time. We have more processing power, not just from a programming standpoint, but from an operator standpoint in the same footprint. The ability to combine operations and avoid moving parts to additional machines for secondary processing. We have so many customers that are always in that mode of pulling the part off the machine, moving it to another machine. It always looks good on paper for cycle balance, but at the end of the year, they don't see the monetary gains from doing it that way. So more tools in the cut. A third turret instantly gives you the ability to have 3 tools in the cut. When an application is optimized to take advantage, the result is a dramatic reduction to cycle time. It's like we said, simple math. I've got more tools overlapping at any given time. More space efficiency. So a third turret essentially adds 50% more machine with no change to the floor space requirements. We all know that square footage is at a premium these days, and it's not just from the building standpoint. As we add any type of machinery, we're adding people to maintain that machinery, heat in the building, lights, and all the rest that adds to the overhead of any part that you're creating on that machine. So if we can increase 50% of that machine in the same amount of floor space, we're money ahead on every part that comes off that machine. Increased part complexity. So we have the ability to have more tools for more processes, easily tackle challenging backworking. We know that parts typically are backworking heavy, and we can make more complex parts cost effectively. So we can take a look at these and drill down a bit more. So higher tool capacity by increasing the tools available by 50%, it allows you to process significantly more complex parts. More effective application of standard tooling minimizes or eliminates the need for custom tools, i.e. if I'm having to use a lot of form tools because I don't have a lot of positions left on my turret, this will allow me to put in a center drill and have multiple drills utilizing that same center drill. And it's going to keep the cost down and not have to buy customized tooling. Extra capacity to accommodate redundant tools reduces the number of changeovers. If I've got more residential tooling that I can leave in that machine, I can easily go up and co-utilize that tooling for a different part and not have to have an extensive changeover. Complicated backworking. With the ability to serve either spindle, a third turret allows more efficient cutting of complex features on the back end of the part and allows the programmer to choose work front to back or back to front. We all know that one of the first things that we do when we're trying to process a part is we're going to look at that part and figure out which way we're going to attack it from. I can be severely limited with just a single or a dual turret machine in how I'm going to attack that part. By having the third turret, being able to do more complex backworking or a lot more backworking is going to allow me to make better choices or have greater versatility in moving that part around. Cost effectiveness. A third turret provides programmers the ability to balance operations for a much wider range of parts, allowing for much greater machine efficiency, spindle utilization, as well as empowering you to bid on and win more complex work. One of the things we're always battling is the status quo. If I can bid on more complex work because I have more processing power in that platform, it's going to allow me to bid on higher margin work and have greater profitability and be more competitive than the next guy down the street. So that brings us to additional processes. Some of the additional processes that a third turret provides us is the ability to do pinch turning. Pinch turning using two turning tools at the same time, pinch milling using two milling tools at the same time, dual process drilling, which we'll define a little bit more in a minute, flexible part support options, and the power of dual spindles. It's the last thing that we want to talk about in this. So pinch turning. Pinch turning is applying tools in opposing directions that stabilize the part by balancing out those cutting forces. We can also rough and finish at the same time in a single pass, or maybe I'm taking multiple roughing passes. I could have two roughing tools at the same time, extending my tool life because I'm breaking that up over two tools, but also I'm whittling that part down a lot faster. We've got a quick video here that we want to, or animation that we're going to show you. In this pinch turning, hopefully it will boot up quickly and technology gods will be. So this is a simple pinch turning animation. As you can see, we are plunge turning with these grooving tools. And as you can see, opposing forces helping to balance out and stabilize that cut. Pinch milling. Getting into pinch milling, part stabilization, once again, via balanced cutting forces. Increased metal removal rates by the ability to put two roughing tools in here, machining off material allows me to quickly whittle down a part. And we can efficiently create hex parts out of round stock. We've got so many customers that are trying to process something faster by putting in expensive hexagonal stock only to machine away almost all of the hexagon to leave just a small area or a flange with wrench flats in it. Now note, really, really important to have both an upper and lower y-axis turret for doing this pinch milling. We've got another little video that will queue up here for you that has animation as well as a real-world part that we created on one of our C machines that will show the benefits of those cutting forces. So at first, as you can see here, we've got an animation. We're putting some flats in here. Once again, you can see us. Got opposing cutting forces. We're going to drill through that flat. Now, this next part is a real-world part where we were doing a little over half-inch roughing end mills, both cutting at the same time 180 degrees apart. And because we balanced out those cutting forces, it's allowing us to take that C-axis and twist that part and cut that flute, those two flutes in that part. Simultaneous drilling. So simultaneous drilling, part stabilization by a balanced cutting forces, once again, highly efficient for multi-hole parts. Now, most of them are going to be 180 degrees apart, but I could have multiple rows in those parts too, as well. Simplifies deburring operations. I could be using one drill to deburr while I'm drilling with another. Also, the co-utilization of standard drills with complementary tools, such as taps, deburring tools, center drills, and large diameter drills. Got a little animation here too for the drilling. As you can see, once again, opposing forces. So we're going to be able to go in and drill into this part efficiently, minimal part deflection, and very quickly make 4 holes in the part. And lastly, part support. A third turret can be applied as a cradle to support downward milling and drilling forces or side milling forces. We can support longer parts during back work and counter spindle utilization. So if I had a long shaft that had very little back working on the end, I could have that swallowed in the counter spindle while I have the main shaft now sticking out of the main. I can use that lower turret to help support that, i.e. either with a cradle, or it can serve as a hydraulic follow or steady rest for that long shaft work to aid us in supporting that part. We've got a real-time video that you'll see here of us making a bone plate, bone screw. Take you through it. As you can see, we have that cradle come up, and we are helping to support the side loading forces as we rough off a flat in that. You can also see in the background, we've got several of those cradles all queued up in that turret to come in and support that part differently. In this particular case, now it's supporting it vertically, so I can go in and dish out the convex area for that bone screw plate. I think everybody can get the idea on this one, so we're going to jump out of that video. It's a little long-winded. And lastly, what I'd like to talk about is dual spindles. So dual spindles, a machine with a third turret will frequently include dual spindles instead of a main spindle and a sub spindle. This allows any work to be completed on either spindle, offering further flexibility to your programmers and your operators. If I've got a sub spindle that has smaller bearing design or less horsepower or less torque, I don't have the ability to take the same cuts on the backside as I'm taking on the front side. You know, the material doesn't change, the feeds and speeds don't change, but the machine's capabilities do. So if I've got a diminished counter spindle to do my back working, it seriously starts to negate the benefits that we talked about with a third turret. So, in summary, the benefits of a third turret: we've got immediate productivity gains, the ability to process more complex parts, and additional processes to provide flexible options. That concludes the industry perspective. What I'd like to do now is turn it over to Mr. Mike Huggett, that's going to give you the index perspective as to why we think the C-Series best utilizes all of these benefits of a third turret. So with that, I'll turn it over to Mike.
My name is Mike Huggett. I'm the National Sales Manager here at Index Corporation. I cover North America and Canada with our sales team. And I'm going to do a brief infomercial on the Index C-Series machine tool and the advantages Index has over its competition. Can you hear me now?
Yep, we can hear you, Mike.
Okay, great. The main advantages of the C-Series, when we're talking about it, is accuracy. And its accuracy is achieved through its stable design and almost zero thermal growth. Its strength, having powerful motors both in the driven tools and in the spindles, and box ways for added rigidity. Its speed and acceleration, both in the main spindles and driven tools, but also in the non-cutting times, the ability to go from 0 to 1G acceleration in less than 20 millimeters. And then versatility, allowing you to have rapid changeover and go from there. The C-Series design is a dual box way, dual Y-axis turrets, both the upper and the lower, feature full Y-axis and box ways, and then a third turret that is above the secondary spindle that has a X-axis movement in it. You have full easy access to all the turrets, making it easy to load and unload tooling. When you're standing in front of the machine, the two upper turrets are at about chest high, and you can reach out to those by putting your arm directly straight out in front of you, about halfway across the turret without even stepping in the machine. It's extremely thermally stable and has the fastest rapid traverse rates in the industry. The last thing we'll talk about is the free chip flow and getting chips out of your working environment. So the turrets themselves are on an innovative plate guideway system. So you have two box ways, both on the top and the bottom of each of those turrets. The turrets are directly inside the machine bed, so there's no stack up of tolerances. If you've ever taken a look at a slant bed lathe, you have a turret on top of another wedge, and those two wedges move to give you your Y-axis movement, but there's huge amounts of mass and weight. So you're constantly fighting slipstick and movement on those areas, to where ours is a very minimal overhang to the center line of that turret, allowing for maximum rigidity. Also, because it is box way, you have the advantages of the dampening of those box ways, which give you a higher metal removal rates and up to 30% longer tool life for better long-term accuracy. The turret movement themselves is 100% unique to our industry. It uses a kinematic series of levers that are backed up by linear scales to measure the distance between the slides and counterbalanced with the coil spring. This effectively gives us minimal thermal growth with 100% compensation for glass scale measurement. This is a simple video that allows you to see what's going on. On the left-hand side, you see the actual turret going up and down, to where on the right side, you get to see what's happening in the background. When both ball screws are turning in the same direction, the turret moves in Z. When they're moving in opposite directions, it moves in X, and it can move in any combination of X and Z in any diagonal, straight, or linear motion by the speed of which you move those ball screws. 100% unique to the industry and allows you to have minimal overhang and maximum rigidity. Extended tool life. Index single slides are double dampening quality because we're combining both sides of that box way. So we're not just pushing on the top of the box, we're sandwiched in between it, which allows us to have almost 30% longer tool life and better surface finishes. Whenever you're using a roller guide system, that roller guide will pick up vibration and will sound like a tuning fork and transmit that throughout the casting. By using a box way and by sandwiching those ways in between it, we eliminate up to 30% of that vibration, which allows us to have a longer tool life. Dynamic and fast movement. The turret slides allow us to have extremely fast acceleration, almost 60 meters a minute in our rapid traverse plane, with 1G acceleration achieved in 20 millimeters of stroke. If you've ever watched a turret move, you have to get out of the way due to different tool lengths and interference points. So you finish a cut, you move out of position, you rotate the turret, you move back into position. When we can do that at a 60 meter per minute rate with 1G acceleration, it's lightning fast, which allows us to be extremely fast in our non-cutting times. Now, when we talk about the three turrets, we do have two Y-axis that can be applied simultaneously at the main spindle or at the rear spindle to optimize your machine balance. Our Y-axis have over 40 millimeter of travel, which helps to reduce cycle time, allows for simultaneous turning and milling, and then simultaneous cutting on that second spindle, all the things that Craig highlighted in his presentation previously. The main and sub spindle are perfectly balanced to allow for highly powerful and productive acceleration and deceleration. They are liquid cooled, built by us for us in our factory, to where we even do the windings themselves into these spindles. So you can go from 0 to full RPM back to full RPM the opposite direction in less than a second, and we're able to synchronize our C-axis at full RPM. Literally no delay. If you've ever watched a cutoff cycle on a Fanuc machine, it can take up to 8 seconds before you even engage your cutoff tool. We're doing it almost instantaneously. Free chip flow. I love this picture because it lets you see how easily the chips get out of the way of the machining environment. Allows them to pass vertically, just like on a horizontal machining center. And you can also see we have no accordion way covers up above. They're all flat way covers, which helps to eliminate any contamination getting up and over and behind those covers themselves. So it gives you an extremely high process reliability without having to worry about chip buildup on non-cutting areas. Flexible cooling concept. We chill our spindles, we chill our hydraulic units, and we chill our control cabinets, all to make sure that we're extremely thermally controlled for optimized precision. You do have the ability, when you buy more machines, to put a heat exchanger in and run multiple machines off that central unit. Northern customers like that option because now they can use that for heating in the winter and not put additional heat into their building in the summer. So it's both flexible and optional for the environment. High tool capacity. We have up to 14 stations per turret for up to 42 tools. All stations are driven with 8,000 RPM. Same as the spindles apply, full RPM, back to full RPM the opposite direction in less than a second. We have a VDI system for tool change that minimizes your setup effort. So what we're talking about when we do that is our patented W serration system built directly into our turrets. It uses hardening ground grooves for fast and accurate tool changes. Holders can be locked in place with a single screw, and the W serrations lock them into position for maximum torque. You actually have almost 3 to 4 times the torque on the W serration than you do in a standard bolt-on turret that's on most machines today, a BMT or a Mori style turret. The beauty is that you can take a tool holder off, put it on the shelf, and put it back in that machine 3 hours from now, 3 days from now, 3 years from now, and it'll repeat to a plus or minus 2 microns, perpendicular and parallelism. So you're no longer tramming in your tool on your machine. You're setting your offsets offline, dropping that mechanically back into that W serration, and knowing you have maximum rigidity and repeatability. We use an integrated part unloading arm. We're not going to shoot a part into a basket and mar it up. You have the ability to pick up from the main or the counter spindle. It's picked up with a robot arm and loaded onto a conveyor and pulled softly outside the machine work environment, maintaining your part's accuracy and beauty. You have awesome service access on these machines. One of the nice things that the C machine is an innovator with is it moves the control cabinet off from behind the casting. It puts it in parallel with the bar feeder. What that allows is you have full access to the back of the machine as a maintenance department. But the nice thing is none of that heat from that control cabinet are affecting the back or the casting of your machine tool. So we're 100% removing another interference point or point for thermal instability by moving that parallel to the bar feeder. Small footprint. By offering higher performance with less floor space, we get to use optimal use of your valuable production space. Our competitors can put 3 machines in the space that we can put 4. Very thin and compact, allowing us to have full access and easy operation. So in summary, the C-Series advantages are 3 tools in the cut for the lowest cost per piece, flexible design for diverse applications, fastest kinematics for maximum output, and compact design for maximum floor space effectiveness. So what I'd like to do is give you a simple real-world example of a shop floor part process and how using a 3-turret index machine can be more cost-effective and make you more profits. So let's assume you get a contract that's for 91,000 pieces. So that equates to 1,750 parts per week over 54 weeks. Let's assume that you're able to operate 24 hours a day, 7 days a week at 80% utilization, which equates to about 134 hours per week. Now I'm going to establish a shop rate of only $30 an hour. I hope most of you have a higher shop rate than that, but in today's times, we don't know what we need to do to keep busy. So we're going to keep this at a $30 an hour shop rate. We're going to assume that your old process is a standard 2-turret main counter spindle lathe versus ours, which would be a C200. The cycle time under your old process is 270 seconds. And to make 1,750 parts per week, you're going to require 131 hours to run that. Your shop rate of $30 an hour times 131 hours is almost $4,000, $3,937. Divide that out by your number of good parts, 1,750. That means your shop rate is effectively $2.25 per part. Let's do that the opposite way. If the index cycle time is 92 seconds, we only require 44 hours to run that same part. And your shop rate at $40 an hour, your shop rate is only 77 cents per part. Okay? Now, What about the cost differential between the old 2-turret machine and the new Index 3-turret? Well, the old process, the machine cost is $350,000. You've allocated 97% of that machine to make 1,750 parts per week. So your annual part production capacity is 93,000 parts. So you divide 93,000 into 350,000, that's $3.76 per part to pay off that machine in 1 year. If you take a look at the Index side of things, our cost is $685,000, but we're only utilizing 33% of that machine. If I go to the same 97% rate, I can make 273,000 parts in a year, paying that same machine off in a year, doing over 3 times the capacity. My part per machine cost is only $2.50. So now look at them side by side. Your shop rate goes from $2.25 to 77 cents. Your cost per part drops from $3.76 to $2.50. Your total cost per part, shop rate and machine cost, goes from $6 to $3.27, almost half the cost. In addition to a lower cost per part, the C200 has almost 300% of the capacity of your previous machine while taking up less floor space. I'm going to show a video of a real-world example of this. This is an aerospace part that was made on a conventional 2-turret machine, 42 millimeter bar, and the competitor quoted 274 seconds. We were a lot faster. Now in this video, you get to see a lot of the things that Craig talked about. Overlap turning, pinch turning, roughing and finishing through one pass, utilizing 2 turrets. Simultaneous use of the counter spindle with the other turret. 1,000 PSI on any tool at any station. Y-axis off-center drilling and tapping. Z-axis positioning. Watch how fast this is. Can't even see it. Utilizing those 3 turrets to work on many different positions of the part at the same time. Driven tool capacity, all turrets at any position is driven. And all of those thermally stable processes allow you to hold extremely tight CPKs on critical dimensions with amazing finish and tool life due to the box ways. Rigid tapping, every position. And there's the unloader. There's the transfer and the cutoff. So when we look at the cycle time comparison, they were 274 seconds. We were 144, almost 130 seconds faster. Finally, we'd like to say that during these challenging times, we're here to help, and we're here to help you prepare for your recovery. We're able for optimization of your existing applications. If you have a part that you want to get better at, we're more than willing to work with you and our applications teams. We could do time and cost studies to help you do a justification of that. Our service department is here for preventative maintenance and upgrades. And then we're always here for operator training, maintenance training, whatever else there may be. So what we'd like to do now is open it up for any questions and turn it over to Jim May. He'll ask us those questions directly.
Okay, so we've got several questions here. Obviously, as we're going through these, if anybody attending the webinar has any additional questions, please just enter those either in the chat or questions box. The first question we have here, is there still a benefit from a third turret if you're dealing with fairly simple parts?
The answer to that is absolutely. And the reason why is you can take advantage of the roughing and finishing at the same time, balance turning, balance milling, those kind of things. Even if it's a basic part, you're still going to take advantage of that. Not to mention, one of the key components of why an index machine is 25 to 35% faster than our competitors is our non-cut time. So the more tools, the better, but also by utilizing the combination of work availability and balancing out from the front to the back, even a basic part will be faster on a 3-turret machine.
Okay. All right. The next question we have, simultaneous or balanced turning and milling have been in the industry for quite some time. Now a balanced turning calls for a rigid and higher horsepower spindle. How does the turret contribute to enhancing or improving on the spindle power and torque situation?
Okay, so that's kind of a two-part question. The first part is you have to have a powerful spindle to be able to do that. Our spindles we build in our own factory. We do all our own windings and everything else. We have some of the highest torque ratios in the industry and a very strong, powerful spindle, both in the main and in the sub spindle, to be able to balance that work out effectively. The next thing is making sure that you have the rigidity and strength is the turret design itself. Is by us sandwiching that turret in between two box ways and then using that kinematic movement for that, I have the most rigidity of any machine out there, period. The distance from the center of that box way to the center of my turret is smaller than anybody else's machine tool out there. If you think of a slant bed lathe and the distance from the center point of the movement of that slant bed lathe to the center point of the tool itself, it's an extreme distance away. So you have to combine two operations or two major components come into being able to effectively pinch turn with torque, and that is the rigidity of the machine that you're cutting on and the strength of the spindle to drive it without stalling it out.
Okay. The next question we have, does this 3-turret technology apply to machines from Index that are both Index and Traub brands?
You want to take that, Craig?
Say that question again there. Jim?
Does the 3-turret technology apply to machines from us that are both the Index and Traub brands?
Yes. So when Traub was taken over by Index, one of the things that Index did was to apply a lot of the learning that they already had in their current turning centers over to the Swiss side. So you will see all of our Swiss machines are turret machines, and most of them can run in a fixed spindle application or a moving headstock application. But more to the point, we also have front working and back working drums on those machines to get up to 4 tools in the cut simultaneous yet completely independent of one another. So yes, it is across the board.
Okay. Next, do we need separate programming software for this, or is it in the build?
Mike, you want me to take that again?
I can start, and then if you want to add to it, you can.
Okay.
Both the Traub and the Index machine have standard cycles built into it. So programming at the machine in a conversational manner is an option on both machines, and it comes standard on both machines. What we do offer as an option, an additional cost, is either WinFlex for the Traub or virtual machine for the Index side of things, which allows you to 100% program that machine offline and simulated without having to go to the machine to prove out your part program. So those are two distinct advantages for that. Now, in today's world also is a lot of people want to use their own offline CAM softwares for that. And I would say that the two best options for Index Traub in the marketplace today would be Esprit and Siemens software for programming offline, or utilizing the Index virtual machine or the Traub WinFlex. Those are going to be your best components for it, but they are not required to program such a complex machine.
Okay. Regarding driven tool holders, how much power, especially torque, can be delivered through a VDI shaft versus a bolt-on holder whose drive shaft does not have to squeeze through any tube?
Okay, so we have some Maury fans out there. We have the ability to go up to torque doublers and triplers, also speeder doublers and triplers or fluid-driven spindles. And I would put our strength and rigidity on a one-to-one test with any competitor out there. We accept the challenge.
Yeah, I think another thing to point out is also the W serrations. One of the issues that VDI tool holders have is they have play when they interface with most turrets. You don't have that play going on. It isn't just about the shaft, it's about the rigidity of the holder in regards to interfacing the turret. With the W grooves, we are exponentially increasing the rigidity of a standard VDI holder. And I agree with Mike.
Okay, it looks like that is all of the questions that we received today. So thank you everyone again for taking time out of your schedules to join us. Later in the week, we will send out an email with a link to a recording of this webinar if you'd like to review it or share it with any of your colleagues. And have a good rest of your day.
Thank you very much.
Yep. Thank you, gentlemen. Ladies and